One of the biggest benefits of 3D printing is you have the ability to make parts that are either no longer available or they're too expensive to bother with. So in the case of an old toy like this one, this is a 2002 Gemmy Homer Simpson. He's supposed to sing, he's supposed to dance as well. And when you press the button, he does neither of those things, so there's definitely something going wrong. When you move the arm on this side, it's loose. It looks like it's not connected to anything. And on this side, it's solid like it's supposed to be. And the head seems fine as well. So the plan for today, let's open Homer Simpson up. We're going to dissect him, find out exactly what is broken on the inside. I suspect, like a lot of these other Homer Simpsons, that there's something plastic broken. We're going to design a replacement piece, hopefully even better than the original so it doesn't break again. And we'll install it and test it out as well. So stick around. So Homer has been broken for quite a while. I think it's probably 7, even 10 years maybe. I'm pretty sure I took Homer apart a long time ago. This is my wife's Homer. It was her dad's, and they had a lot of fun with it. They got a lot of enjoyment out of it because he's pretty silly. But the thing is that he just doesn't work properly. I think the singing was working and the dancing was only partially working, but now none of it is working at all. So I really want to get this fixed up. And I think this is a common problem with these. Some of them may end up going in the garbage. I do see some on sale on eBay where they're saying that the upper body isn't working properly. So obviously this is a common issue, and it would probably be good to have a 3D printable fix for anybody that runs into this problem for these old toys. So this is what Homer looks like. Good on the outside, but I'm thinking if we raise the clothes, it's going to look a little bit more plasticky. Well, let's get him all disassembled and see what's going on with Homer. So we have a wire that is completely disconnected. That one I think is going up to the motor. And then on the back of the PCB, there is also some damage. It looks like a bit of a scrape mark, but I think that's mostly superficial. And try and slip these sleeves off of his hands. Hopefully they come off. Look what we have here. We have a broken piece on this side. And then this side is a little bit more complicated. I think the head is attached to this section. It looks fine, although I do notice a few little stress marks. So I think somebody has probably grabbed the arms when they shouldn't have and stressed these pieces. Before I do anything else, what I'd like to do is see what's going on with the motor, since nothing's actually happening. Okay, we're going to power this on. Oh wow, that's fast. 3.5. He's still going really fast. All right, so at least the head's moving. This side's moving fine. It looks pretty good. But obviously no movement out of this arm. So that's the side we need to work on. I'm going to go ahead and try and get this taken apart, and we'll have a really close look at this section that we need to fix up. So here's the piece that we need to replace. You can see it's obviously fractured. Interesting that the bottom section there doesn't have any of that white. So I wonder whether maybe that was an issue during the molding process and why it might have broken, kind of opening up on this section a bit easier and then breaking on the top. So there is enough information here just with what's left to be able to replace it. So normally with a part like this, I just jump directly into Fusion, but I will say I get better results when I first sketch these things out. I can dimension them all at once, make sure that I have all the dimensions that I need, but I can also make changes really, really quickly with a pencil, where it's a little bit more time consuming in a software like Fusion, where you may have to go back and adjust other things. So I'm going to do that sketch first, and then we'll maybe make some adjustments in the sketch too to make it a little bit more 3D printable and a bit stronger as well. So this is called a Scotch yoke system, and it has this elongated slot which rides on the pin. Now I think for the purposes of keeping their mold as simple as possible, we have a lot of straight lines, a lot of square corners. So we're not limited by the mold now. On this side we have all this area to work with, but if you look at the piece that was sitting in it, it's only taking up a very small portion of that width of the pin. So I think for the purposes of this and making it as strong as possible, we're going to actually make it a little bit wider, and that's going to help us with 3D printing it as well. So that will actually drop down, and it'll probably drop down right to the bottom of these legs that come out as well. And then on the bottom, what we'll have here is a recessed area. And I have a little trick because this is a little bit difficult. I want to print this without supports. So what we want is a bridge to come across here and provide a really nice surface on the bottom. But if you have a hollow going all the way through like this for the slot, you're not going to be able to get that bridge, and that's going to require supports. What we're going to do as well is taper this boss. It's probably going to come down to a chamfer or a fillet as well. Chamfers are easier to draw than fillets are. And as much as that is possible. And also, this reinforced area too can come down on an angle as well. So overall, we're going to have a much thicker part. It's going to be a lot stronger, but we are going to end up with a left-hand side and a right-hand side in this case. Not really a big deal because we're going to be replacing one of these pieces. Now what I will do is I will provide a left hand and a right hand in the download down below there. And that way, if anybody has this particular Homer, I doubt that that's the case, but you can download whichever one you need and replace only the part that you need, or replace both of them. So now that we've got this drawn out, I'm just going to transfer all of the dimensions that I need from this small part onto here, and then we'll jump over to Fusion. One thing I noticed while I was drawing this out is that the stroke of this crank is actually much smaller than the size of the slot. So we have 5.43 to the outside here. We can multiply that by 2. So basically 11 millimeters, and we have a slot which is about 18 millimeters. So it's quite a bit longer than it needs to be. We could technically shorten this if we wanted to. And if we did, it would end up being a part that's a little bit less prone to breakage. And for reference, this is how the arm actually sits in this little cradle. When I first started using Fusion, I would create a very basic sketch, then I would extrude, then I would create another sketch on top of that extrusion, and so on, and it would get really, really messy. I'd have sketches all over the place. I'd have to name all of those sketches. So what I like to do now instead is try and get as much onto a single sketch as possible. So I'm going to create a sketch. I'm going to do it on the top plane. And what I mentioned before about the slot length being a little bit too long, I think I'd like to shrink that down, but we can play around with that number a little bit too. So what I'm going to do first is create the slot. I'm going to go outside to outside for our slot, and it's going to be centered on our origin point as well. And that way, any changes that we make, it's all going to be based off of the center point. It's going to be pretty organized. All right, and now we can just extrude our part. Because we have only a single sketch to reference, what we need to do is either start from our object, we can do that and extrude up from there, or if we have the overall dimension, we'll say join, and it is 9.03 millimeters, I believe. And we'll just do the rest exactly like that. I've got a little gusset in there. It's a bit better than the original one because the original one was very square. And this is basically a good replacement if we were doing an injection molded part, but because we're doing a 3D printed part, it's not really going to be as strong. And we also have the issue of having to get supports on the bottom here. I really don't like the idea of having to put supports on. So I can go back to our sketch, and what I'm going to do is just extend some lines up right to the top. And we also have a bit more wiggle room in here, so we have 5.5 millimeters. And we'll probably go with 5 just to give a bit of clearance as well. I really don't want to use supports, so what I'd like to do is find a way that I can allow the 3D printer to bridge this area properly, but we have a slot in the way and we have a hole in the way as well. So if I go back to our original sketch and I click on our sketch, and there are different planes, different heights, so I'm going to extrude from this section, and I'm going to go 0.2, and I'm going to join that one, and I'll do the exact same thing with this hole, 0.2. And now we have two areas which can both be bridged pretty easily. They're filled in at the moment, but it's really easy to push through that material or even cut out that material later on as well. What I like to do with parts like this, I want to try and make them as strong as possible. And what we can do with the part, if we can actually tilt it slightly on the 3D printer, but we can actually do one more further. We can actually have it a compound angle. We can have it tilted in one direction and tilted in the other direction as well, just a very small amount. And in this case, because I'm on the center plane, we'll actually extrude it in both directions. Extrude two sides. One side is going to be 2 degrees, and the other side is going to be -2. So I do have a parameter here where I can change the slot length. I think I'm just going to leave the slot length because when I change it, it changes the distance for the gusset here, that little bracket in there. So I'm just going to leave it as it is. Everything else seems to be fine. So when I took this apart, it looked like we have an issue. Oh, okay, good thing I have photos of this. When I took this apart, one of the wires was disconnected. Now both of the wires are disconnected. So I printed the new design. This is nylon Sunlu Easy PA, and I would have preferred natural color, but this is what I had. So results turned out really nice. They seem pretty strong, and you can see there, because I had this set at a compound angle, tilt in 2 directions, that I have this really unique top surface, and also the same type of thing for the bridging. But with that said, I did actually run into a little bit of a problem, so let me show you what I mean. So this steel pin actually just gets pressed in. It's knurled on one end. It gets pressed into this nylon piece here, so it can come out fairly easily. And you can see how it just nestles right in to that recessed area. Really nice there now. But with that bridging at that funny angle, it really gave a kind of a rough surface, and it's getting hung up on occasion. And I don't like that at all. So I decided to redo the design and tweak a couple more things as well. So I used my Bambu H2C to print these parts in a heated chamber, 60 degrees Celsius, and these 3 are actually all different from each other. Let me pop this off and show you what I mean. So the first one here is basically an exact replica of the original, other than the color there, and I had to print this one with supports. I did change the density of the support, the top layer there, the interface, because it didn't seem like it was going to work very well. And then this one here is actually the newest version, and then this one is just the same as the one we had originally. Well, the good thing is that it's a great bond. The bad thing is that it's a great bond and it's really tough to get the support material off there. Now, I did increase the density of that interface layer and that might have something to do with that. But I'm just going to work at this for a few minutes. All right, so I was not being careful enough and I'm pretty sure that I broke one of these wings off. And I can move to this one here. Actually, it looks really good. The bridging isn't perfect still, but I think it's good enough. You can see on the back there how it did actually bridge. And I'm also just going to clear out this hole. So basically that section that's bent goes down towards the bottom. So it locks in really nicely. Let's see if we can get this mounted. When I moved this around a bit too much, this wire came off the motor as well. So I'll fix that in a few minutes. It's working well. That's good. And this arm is really solid too. This one here, they use glue gun and it's loose. So I think maybe, now I think I'll leave the original part, but I'll do the glue gun again and just do a better job of it. It's making a little bit of a clicking noise. I don't know where that's coming from. Let's see. Oh, there we go. Perfect. There we go. Now we just need to fix the area with the glue. Yeah, and it literally is just glue gun that they put on there. You see, it's rubbery. That is it. Wow. You can see how much slop there is in there. If I hold this still. And I'll put a bit of glue on this side too, just so that they match. Or at least it looks like I tried to get them to match. And we can pull Homer's pants back up. And this might be the hardest part, to try and get his arms back in. This is going to be kind of difficult. Whew. Wow, that was a lot harder to get that back on than I expected. Oh. Okay. Come on, Homer. Come back to me. Come back to me, Homer. Hey, we have movement. And no sound though. Physically, Homer's in great shape now, but mentally, I think he's got some issues to work through, or really I have some issues to work through with him. Unfortunately, I don't know enough about PCBs to be able to diagnose this problem properly. So when I press the button, sometimes he moves, sometimes he doesn't. I assume that music is supposed to be playing and maybe that's why he's not always moving. And this time he's moving quite a bit. So that must be a long song. So what I was thinking was to create a PCB from scratch to replace the existing old one. And I would even include a slot for an SD card, a micro SD card, where I can put some music on there and we can have a lot more selections. So a button press would go through a random selection process. He would do a different dance or a dance for each different song or whatever I want Homer to say. So if you have some interest in that and seeing how that would be done, let me know in the comments down there below and I will get set up to make a video specifically about PCBs and creating them from scratch for something like this. Just about every single week, I'm also creating designs that I don't make a video about, so I'll start putting them in the links down there below. They're usually just fixes for things around the house. In this case, it's a drain plug that is also parametric. You can change the size of the plug so that it fits your sink or it fits your tub or whatever you need to plug. So that's for this week. It's supposed to be printed from TPU as well. Also check the links below for my top picks of my 3D printers. Thanks for watching, take care, and I hope to see you on the next one. And now I'm just going to solder this piece back to like the original. So first we have a locking clip to go back on. Is over the top. Like so. And I don't know how to get the solder to stick on there.